my name is Dan. I'm not sure how many people here are people who grow plants for the purpose of food. Some more than half-ish. And other people here as a consumer, curious about topics. Any of you guys want to raise your hands? Just a couple. No one else wants to say there. Okay, so I can talk farming practices. You can talk like dirt. All right. I'll probably talk other topics as well. Formally, this is a teaser. This is a free 2-hour introduction to a 2-day course that will be happening in 3 weeks. If you do find yourself feeling like there's more information here than you are able to ingest, know that that's the purpose of this event, is to leave you feeling like you want more. So I will hopefully accomplish that. I'll just like to give you a couple details on background. I think there's a bit of a background noise.
Yeah, maybe
Anybody who's in the back row and having a hard time hearing, there are chairs up here. She's going like this already. I'd rather not shout. So feel free to come up. You're not going to come up, that's fine. All right. So quick background on myself so you know who's talking to you, for whatever it's worth. I personally grew up on an organic farm in Massachusetts. My parents, when I was 4 years old, bought a piece of land that had a couple acres of fields and a lot of forest and swamp and rocks. They built a passive solar house. They had a root cellar and a wood stove and put it in an orchard, and we had a milk cow, and it was kind of a homestead situation. I think we started a farmer's market in the center of town in the mid-'80s, and we were certified organic in '86, started a CSA in '91. So I basically have spent most of my life as a farmer, so that's a part one. And my parents were the kind of farmers that couldn't make a living farming, which some people have heard about. Anybody heard about this one? You can't make a living farming, so they got a day job so they can farm. So my parents' day job was running an organization called NOFA, Northeast Organic Farming Association. We have 7 state chapters of NOFA in the New England sort of region, and New York and New Jersey. So I have a background as a farmer, but also B in the movement, as it were. And I sort of was like, well, we all have our issues. This is the way I was brought up. But when I got married and came to terms with the fact that I was probably going to have a family and needed to figure out a way to pay the bills, and I had done nothing more than manage my parents' farm for not much money. I had to have a serious conversation about where I'm going with my life, and I hadn't been able to find anything else to do with myself that felt better. Like, I can't work for other people. I can't work inside. I kind of like being independent and on the land, and that sort of lifestyle is really appealing to me. But I was like, I also can't make a living farming. So about 10 years ago or so is when I started down this path of trying to understand more what's going on. And I was sort of brought up in the organic world with my nose a little bit up in the air. Do we know about that? Organic people, they're like permaculturalists or biodynamic people or local farmers or whatever. Everybody's got their sort of nose up in the air. Do you know about this? Yeah. Well, I speak from experience. One day, I think this was, I think it was actually after I got married and I was having these thoughts. I was walking across the driveway to check on our dog, Snowball, who had the previous week been run over by one of our CSA members. They hadn't seen him in the driveway, and they were driving an SUV and drove over his rear end, and whatever. He yelped, they stopped. It was like, "Oh, sorry, we drove over your dog." Like, well, he's he's still alive. Anyway, he got to hang out in the house for a couple of days and chill out, but then he was back outside because his job was to chase coyotes and keep them away from the chickens. So I was going and checking on him as I was walking across the driveway to go pick potato bugs. Anybody, you guys have potato bugs down here? Colorado potato beetles? Some people know what those are. anyway, if you got potato bugs, usually they eat your potato plants really fast, and then they don't have a potato crop. So what we would do is we'd take a 5-gallon bucket and we'd knock the potato bugs. You just walk along the bed and knock the potato bugs into the bucket. And so I was on the way to doing that, and I was checking on Stubal, and he had a spot where the skin had been cut, and I was looking, and there were maggots in there. There were like, flies that laid eggs, and there were maggots eating his flesh, which turned my stomach, which is actually, nature healing itself. Eating the dead flesh is actually a way of cleaning out the wound, but it still turned my stomach. And I got to thinking about the fact that I was, repulsed by this larvae eating my dog, but I thought it was totally normal that larvae were eating my potatoes. And I was like, and then I thought maybe if I had, our milk cow was being eaten alive by a flesh-eating fungus, that probably would be a problem. But our cucumbers were eaten alive by flesh-eating fungus all the time, and we just had successions of them. Every 3 weeks we'd have more cucumbers because the old ones were dead. And I got to thinking about maybe organic wasn't actually, or at least what we were doing, part of the reason why I wasn't able to make a living is because our plants weren't healthy. So you can take that as you wish. We'll get back to that whole topic of pest pressure, disease pressure, and nature's speaking to us and our unwillingness to listen to her later. But it sort of precipitated a deeper thinking about things, and I started reading books and going to conferences and attending seminars, and lo and behold, there's actually more information out there than I've been exposed to in my background. And so as I started learning things and practicing things on the farm, I got to a point where we started growing plants that didn't have these problems. And long story short, because we don't have that much time here tonight, my wife and I currently, we have a 24-acre farm a couple towns away from where I grew up. We do about 2.5 acres of vegetables. We've got a bunch of hoop houses. We do pastured poultry and grass-fed beef. And my basic situation right now is that I can make my living on the farm working about half-time, and then I have the rest of my life to go and bop around the country and blow my mouth off, like I'm doing tonight. So because I feel like I grew up in that world and I have a couple decades of experience, and I've learned a couple of things, and hopefully I can help other farmers skip the process of struggling for so long. And maybe we can talk to consumers about a bunch of other things as well. So, but you guys are mostly farmers here or gardeners, so that's great. So what I want to talk about here are some of the basic practices, some of the basic principles, some of the basic things that I've learned, and hopefully leave you with at least 1 or 2 nuggets to go home with. So before I jump into it, are there any questions? I like to sometimes just make a little jot notes of topics people are curious about. Is there anything people would like to have me bring up or have addressed this evening? Yeah. You're so polite down south here. Go to New York and it's like, bah, 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 bah. No. No? You're just ready to, all right, no. Let's get started. All right. So, I'd like to start my presentations with a really simple picture, and I'm going to call this a plant. Everybody got that for a plant? Sort of. This is the ground right here. This is a stick figure plant. I'll put a couple leaves on it. I don't have a green pen. So I'd like to start with saying that most plants are green. Everybody's going to accept that? Yeah? I'm walking you down a path here, so watch what you accept. So we're going to come to some conclusions. Most plants are green because they have chlorophyll, and they go through the process of photosynthesis. We learned all this in school. The recipe for photosynthesis is carbon dioxide plus water plus sunlight equals oxygen and sugar. Everybody knows this? We know what happens to the oxygen. It goes out of the leaves into the atmosphere. What we don't know in many cases is what happens to the sugar. And there's a caveat here. In healthy plants, not all plants, but in healthy plants, a majority of the sugar that's manufactured in the leaf of the plant is taken from the leaf, dropped down, and literally injected into the soil. So nature's been around for a long time. She's figured a few things out. She thinks it's really important for all plants to be green so they can make sugar and oxygen. The plants kick the oxygen into the atmosphere, the sugar into the soil. What's the deal? My suggestion is if you understand this why, then that may shift your whole understanding about how to grow plants. And the why is, to my understanding at least, because in nature, there's no fertilizer. Nobody's adding triple superphosphate or urea or bone meal or blood meal or compost or liquid fish. In nature, the plants have evolved the capacity to feed themselves from their environment. Right? It was a long time before God invented fertilizer. It took them a long time to figure that one out. Right? And I would suggest as farmers or gardeners, the more we can create a reality where our plants are actually getting their needs met from their environment, and we don't need to be constantly spoon feeding them and doing all this stuff, actually the less money it costs to produce crops, and the more likely they are to be flourishing because they're able to manifest their natural potential. So why does a plant inject sugar into the soil? Because plants don't have the ability to digest their food. You may have heard about this one. I like to use the animal plant, sort of metaphor. We understand in many cases things about animals that are exactly the same for plants, but we haven't thought about it. So in animals, we have this dynamic that when a baby is born, like say a human baby, there's a grand total of 0 people living between the mouth and the rear end. Right? The alimentary canal has no one in it. Everybody's okay with this? Just prior to birth, the passage through the birth canal and the consumption of colostrum, that which comes out of the breast after birth before milk, is evolved to establish the flora, the gut flora, right? The people living on our surface and our external and our internal surface. What percentage of the cells in your body are human? Do you know this one? 2? I think they were saying 10 for a while, and maybe it's a little bit more than 10. But a majority of the cells in your body are not human. This is a pretty well-established fact in the literature. So this idea that we have the kingdoms, the animal kingdom here, and the plant kingdom there, and the bacterial kingdom over here, I would suggest is fraudulent reductionist baloney. That we actually have ecosystems. I am an ecosystem, you are an ecosystem, we are all these ecosystems of symbiotic interaction between the kingdoms. We know that we can't digest our food, right? We as animals are physiologically unable to digest our food. It's exactly the same with plants. Plants cannot digest the soil. They don't have the ability to exude the acids and bases to solubilize the nutrients to actually access what they need to build their bodies with. And so that's the situation, as far as I understand it, is there's a symbiotic relationship where the plant makes sugar and feeds the soil life. The soil life eats the sugar, goes out and does their job, and functionally feeds the plant. Right? So when the plant says, I need copper, it takes the sugar molecule, adds a couple amino acids to it, turns it into what's called a plant root exudate, which is food for this specific species, which has this functional capacity. That species eats it, doubles, reproduces, however it grows, goes about its merry life. 2 hours later, it dies, end of its life cycle, and the plant sucks up its protoplasm and has access to that nutrient that it needs. So there's this beautiful virtuous circle where when the plant, basically is able to create the environment it needs to harvest from the environment what it needs by feeding the soil life. I think it's actually a beautiful, elegant system, and one which you don't really learn about by reading most books about farming, by going to most workshops about farming. We have this sort of, what we call conventional ag mentality, this NPK solubility concept. Whether you're learning organic farming or conventional farming, you're still learning about nitrogen, potassium, and phosphorus, solubility, pH, all these things which are, I would suggest, of tangential import. So we've got this area called the rhizosphere, which is where the vast majority of life in the soil resides, and it's in direct proximity to the plant root. And it's in direct proximity to the plant root because that's where their food comes from. And so when we're talking about growing healthy plants, as far as I'm concerned, I don't give a rat's rear end about what kind of plant it is. I don't care if it's an apple tree or alfalfa or a cucumber or garlic or echinacea. I don't care. As far as I'm concerned, when you create the basic foundational underlying environment, then the plant is able to modulate it to get its needs met. So what I want to talk about here tonight are what are those rudimentary environmental conditions necessary for life to flourish. I suggest we need to focus at the bottom of the food chain, not at the middle of the food chain, if we want to create, vitality throughout. Yes.
I have a question. So would it be good to have weeds in my garden because then the weeds are putting the sugar into the soil? Is that
Should I have weeds in the garden? Did everybody get that question? Yeah.
But are they taking
Yes.
nutrients out? Is it a negative?
No.
Okay.
Anybody heard about this term bioaccumulator? Bioaccumulator plants, right? Nature has a way of addressing deficiencies in the soil. There's different plants that are known to be bioaccumulators of different elements. I use the example of dandelions because it's pretty obvious with dandelions. That dandelions are, and many of the yellow ones actually, are calcium bioaccumulators. So, if you add limestone to your soil, the dandelions will go away because nature's got it. Every plant has its functional capacity. Nettles are boron bioaccumulators. So if you've got docks or whatever the different, in many cases, what we call weeds are nature's way of balancing out imbalances. So as long as they're not shading out your plants, I would suggest, that's how I do it at my farm. I don't bother them. Those guys with those deep roots, a nice big tap root, that's doing a job. They're doing work. That's nature improving the system. Where do you see monocultures in nature? All one plant growing by itself. Kansas. That's not nature. Nature doesn't do monocultures, right? And the other question is, where do you see bare soil in nature?
Deserts.
And how well is nature doing in the desert?
Sorry?
How well is nature doing in the desert?
Well, yeah, not so good.
Not so good. They wouldn't exactly say fecundity is the order of the day in the desert, right? Nature, this is maybe a side note, but it's not really. I like to say, you've heard about the concept of Mother Nature? Ever heard about this concept? You may not agree with it, but you've at least heard of it. So if operate with the assumption that nature is your mother, if someone was to go and sort of actively, against her will, disrobe your mother, how would you feel? Rip her clothes off against her will. Anybody? Something comes up inside of you. You don't really want to think about it. We're just going to keep it in the head. You're not going to really feel it. Get out the shotgun. I knew that was downside. As far as I'm concerned, when you uncover the earth, right, nature likes to keep herself covered. You don't see bare soil in nature. We have this idea that it's pretty and somehow appropriate to have bare soil with, one kind of plant all lined up. Nature does not do that. I would suggest that this is a systemic error, a conceptual error. We have a fraudulent definition of beauty and appropriateness that needs to be reconsidered. So, in general, as long as the weeds aren't shading out my plants, I don't bother them. And even then when they are, you can just sort of rip their heads off and drop them and call it mulch.
Because I just wondered, what percentage of sugar are they putting in, but then they're eating all the nutrients, so are they?
So we have this idea that they're competing.
Yeah.
Is there an angry God or a loving God? I mean, is everything a competition or is everything a symbiosis? Do you do better by yourself or do you do better in a community? Is family appropriate or is solitude appropriate? I would suggest, that the way nature seems to do it is that all these plants are growing together and they're actually supporting each other. From a foundational standpoint, we can talk about gut flora. If you are okay with this concept that plants are unable to digest their food and functionally they support different species of bacteria and fungi that digest their food for them, we can call that gut flora. Okay, like we have a gut flora. So think about a cow has a certain gut flora, and a chicken has a certain gut flora, and a rabbit has a certain gut flora. So similarly, a potato has a certain gut flora, and an onion has a certain gut flora, and a lettuce plant has a certain gut flora. And so the broader the spectrum of species in the soil, the broader the spectrum of bacteria and fungi, the more functional capacity there is to do different things, right? And you've got the mycorrhizal fungi who are this amazing filamentous, like, I don't know,
Network?
what's that?
Network?
Yeah, I was gonna go with like fiber optic cables or something. It's like the internet, right? It's like they're connecting everything, and this plant over here is working with these bacteria to solubilize this element, but this element is needed by these guys over here, but these guys are making this element, and this is needed over here, so there's this wonderful symbiosis. And so my suggestion is that they're not actually competing with each other, they're actually potentially working together. And so as long as they're not unable to see sunlight, I would say, we could do with a much more shaggy looking garden, and maybe things would do better. I don't think bare soil is something to be aspired to. I don't think monocultures are something to be aspired to. I think those are systemic mistakes and errors that inhibit the overall system function. But I haven't really gotten to anything of value here. So let me just sort of say that, if you're okay with this conceptual framework, that it's about the bottom of the food chain, what the point I want to make tonight are, what are the basic environmental conditions necessary for the bottom of the food chain to flourish? And that's the real, hopefully takeaway for people. What do these guys need to function well? Anybody got any ideas? Rudimentary. Water is critical. Water? What else? Sunlight. I'm going to assume sunlight. Although some people, especially in the cities, when I go and do workshops in the cities, they think they can plant their garden anywhere in the backyard. And I'm like, that big old tree on the south side of your garden is going to get really in your way. Sunlight and warmth. I'm going to assume sunlight and warmth, okay?
Carbon.
Just carbon or food.
I heard somebody yell out minerals.
I will put minerals down.
Respiration. You get oxygen.
Air. We need water to drink. We need air to breathe. We need food to eat.
Microbes.
The life itself must be there. In many cases, the life itself is not present because of, the historical application of DDT or Roundup or nuclear fallout from the 70s or whatever else happened. So, this is it from my perspective. If you can maintain, in most cases, what is inhibiting people's gardens or farms from flourishing is a lack of one of these critical environmental conditions. So let me just walk through them all in short order quickly, and then we can have a broader conversation if you'd like. So water, we all know the importance of water. I like to talk about the zucchini plant. I'm guessing many people here have grown zucchini plants or summer squash. We'll say sometime in late spring, early summer, end of June, end of May, beginning of June, something like that, middle of June. Your zucchini plants are, a good, I don't know what they are, this big-ish, looking good. They get a nice shiny leaf. You ever seen this zucchini plant with a shiny leaf? You know what I'm talking about? That sheen, that iridescent sheen they have in their leaf. My experience on the farm was that the zucchini plants would start off looking really good, and then, for us, it's sort of the end of June when they're at that stage, and beginning of July. Oftentimes the clouds stop coming, and it gets hot and dry, and then somehow that sheen goes off of the zucchini leaf. Like it was shiny for a while, and then it's not shiny anymore. You don't necessarily notice it right away, but it's a dull green. It's not a shiny green. Anybody ever seen this? Notice this happen? Not just with zucchini plants, but other plants. So just as a sort of an example, does anybody know what is causing that leaf to be shiny in the first place? Wax. It's called the waxy cuticle. Fat. plants have this interesting habit, which is that when they get more food to eat than they need, they stockpile it and the extra food in the form of fat. Ever heard of that idea? Anybody heard about that one? No. No one knows about that idea. You get more food to eat than you need, and you stockpile the extra food in the form of fat, right? Animals do that. If you've got a cow that's healthy, a good-looking cow will have a sheen on its coat, right? It'll have a glossy coat, or a dog, or a child, right? When you're fat and happy, when you're healthy, then you've got a sheen, a nice sheen. When that cow is not getting its needs met for some reason, you'll see the sheen goes away, and the coat is dull, right? Same thing happens with the zucchini plant. So what happens when it gets hot and dry for a week, among other things, is that the soil dries out. And when the soil dries out, then all the people in the soil around the zucchini plant, literally a few hundred billion or a couple trillion individual organisms that don't have water to drink, die. Right? They're dead. Billions and billions and billions and billions of organisms are now dead because the soil dried out. They've got no water to drink. When they die, they stop feeding the plant. When the plant stops being fed, the plant needs to access its fat reserves and starts eating off its fat reserves to stay alive. That's when the sheen goes off the leaf. That's the first step to the green leaves not being green anymore, right? First they're just plain dull green instead of shiny green, and they're not quite green, then they're a little definitely yellowish. You see this happen? Day after day, they go from yellowish to definitely, yeah. Good thing you got a succession plan because they're about to die, right? If you run a CSA and you want to have squash through the summer, in many cases, my experience was we planted successions. That was the only way we were able to have squash through the year. I remember the first time I was able to plant a cucumber in the spring and be picking nice, proper, good formed cucumbers off that plant in October. I was like, whoa, wait a minute. My experience is cucumbers have 3 to 6 weeks before they crash, and 4 months was outside of my range of plausible. I had to double and triple check that this is exactly where I planted the first cucumbers in the spring. I never planted a second planting of them. They never got sick. They just kept growing. So on my farm, the experience I have now is that all those warm weather plants grow and keep growing until frost, which does help with the management logistics. When I had potatoes that got killed by the frost, I was like, no, come on. You're supposed to die in August. What are you doing alive in October? What are you doing? I've never seen potatoes that didn't get dead by the end of the heat of the summer. So anyway, you can take my word for it or not, it's your business. I'm just telling you my experience. So the idea here is if you are unable to maintain hydration, system collapse is a very logical response or occurrence. Anybody ever had a tomato plant that was, say, 2 feet tall, 2.5 feet tall, and it starts flowering and fruiting? Yeah? If that was a human in that life cycle stage, how would you, if that was a human, where would that human be in its life cycle? 20?
13.
I was gonna say 13, yeah. That's a pregnant teenager. She just became reproductively viable and she just got knocked out. She has not built her adult body yet, and she's already pregnant. Yeah, if you could think about it from that perspective. I have a wife I've had 4 children with. I've experienced pregnancy, in close proximity. Some of you here have probably experienced it more closely than I have. We know about the importance of feeding, keeping a woman well fed when she's pregnant. Anybody know about this? Have any experience with women who are pregnant not being well fed?
When I was in the womb, all my mother's teeth fell out.
Yeah. I mean, as I understand it, when a woman does not get her nutritional needs met from her food when she's pregnant, she sucks the nutrition out of her body to feed her baby. I mean, actually, we have cases, this is well documented. Bones get thinner, teeth fall out, etc. We know this with humans. It's not different for plants. So, I'd like to suggest that when our plants are pregnant with babies, that maintaining sufficient nutrition for them is of foundational importance. And, maintaining sufficient water in the system is one of those basic factors that we oftentimes overlook in all of our, other efforts. So, addressing water deficiencies, irrigation is the common sort of practice. On my farm, I've got little raised beds that are, roughly 4 feet, the 4-foot bed with a 1-foot pathway. I make them with a little bed former in the back of my tractor. Usually that's the only time I've got a tractor on the field in the whole year, because they sort of fall in over the growing season. I have drip tape on my farm, so I'll have 3 lines of drip tape in every 4-foot bed. I would like there to be no dry soil anywhere in the field. Right? Some farmers will make it, they'll irrigate they'll get 1 line of drip tape in the bed, but then they're like, oh, well, the side of the bed doesn't matter, we're just watering the plant. And oftentimes they'll cultivate a 6-foot space in the middle between the beds for their tractor to keep the weeds down. And that whole middle area, between 1 line of drip tape in the middle of this bed and the middle of that bed is probably 10 feet. And your moisture width is 4 or 6 inches. And we think that we're watering the plants, but that's not what we should be thinking. We should be thinking about keeping the soil alive. And where the soil is dry and powdery in the middle of the summer, that's why oftentimes our plants are susceptible to infestation and disease. So irrigation is the point. I like to suggest use your hands, reach down into the soil, pick up a handful of soil. If you cannot feel moisture, if there's anywhere in the soil profile where you can't feel moisture, there's an error. There's an opportunity for improvement there. There's this thing called the tidal force, which people have heard about. The tidal force, the tides, every day, twice a day, the water goes up and down in the ocean. My understanding is the tidal force applies on land as well. And if you don't have a subsoil compaction issue with what's called a plow pan, and you've got a decent water table, then your plants will be watered from below twice a day. Through capillary action, the water moves up and down. So you should not need to irrigate if you've got a well-functioning ecosystem. Permaculturalists talk about managing the water, and if you've got any kind of a grade on your land, making sure that you've got ponds, stockpiling water high on the, on the lay of the land, so that it's just gradually working its way down. There's the key line process. There's all kinds of different ways of maintaining water, but I would suggest that maintaining water is of critical importance. All right, so food. I like to say that your soil life does not generally have the ability to take an airplane to Florida in the winter, that they're usually stuck right where they were during the growing season. And if they don't have a root cellar full of food and a freezer and dehydrated and everything else, if they haven't stockpiled food for the winter, they're gonna starve to death. So what happens when the plants stop making green leaves and feeding the soil, there must be some other source of food for the soil life, or they're gonna die over the winter. And people have this experience of maybe having one bed of soil be bare going into the winter, and an adjacent bed maybe having a pile of old leaves on it or a bale of hay. Where I live, when the winter sets in, the snow sets in, the ground freezes, and usually by April the snow's gone and the ground's unfrozen. Definitely by the 10th of April it'll be gone and the ground will be unfrozen. But I guess that doesn't necessarily happen here. I was like, oh, the birds are. Did we hear the birds making spring noises this morning? I was like, huh. It's January. They're making spring noises. Is this normal? Is that for ourselves? My experience when you have one bed of bare soil going into the winter and one bed with something covering it is that when the spring comes, the bare soil bed is very tight and hard and cracked. and the bed that has the hay or the leaves on it, when you reach underneath the leaves, you'll find a loose aromatic soil, worm castings on the surface. It's something you could plant right into. The bed that was bare, have you had this experience? You know what I'm talking about? Right, so I would suggest that the bed that was bare, there was no organic matter or insufficient organic matter, and so the people that were living in the soil started eating that up in the fall, and at some point ran out of food, and what happens when you run out of food is you die, and they all died, and that soil turned to dirt, right? When the life in the soil dies, you no longer have soil anymore, you've got dirt. And so that inert, tight, hard mass that farmers usually till in the spring because it's too tight, you can't grow a crop in it, is because they didn't keep their life fed. My experience has been that when you keep the life in the soil fed, the soil stays loose and there's no need to till it in the first place. So, so we understand the critical role of mulching or cover cropping, or I don't really care what your practices are, but maintaining sufficient food for the soil life, not just in the growing season, but throughout the entire growing season, as a practice. So, okay, I think I can say that's enough to say about that. The point is basically made. Life, we understand the role of life in the system. I've already discussed that. I think the simple step that many people have not necessarily integrated is the step of inoculation. We understand the role of colostrum when a baby's born to establish good, healthy gut flora. We don't necessarily think about the role of colostrum when the baby plant is born in establishing good, healthy gut flora. I like to suggest that if you leave this workshop with a desire to spend 5 minutes and $5 on something, I would suggest it would be on making sure that your babies get colostrum when they're born, making sure that your seedlings have an inoculant, or your seeds are inoculated when you plant them. There's this idea. Anybody raised cows? Know about cows? When baby cows are born, I've only heard this from people who have cows. If they don't get the mother's colostrum, they bawl and bawl and bawl for about 5 days and then die. They don't make it. When baby humans don't get their colostrum, they bawl and bawl and bawl. They're not usually allowed to die, but they're, what's that?
They're sickly.
They're sickly. They're called colicky,
Yeah.
right? There's this alarm system, this really sophisticated alarm system that babies have. Have you ever heard it? It's like a fire alarm, right? It's like it grates on your nerves. It's nature telling you something's wrong. And from a foundational standpoint, we have a baby who's 3 months old, and people are like, oh, you're not sleeping. No, I'm not going to sleep for the next 8 months. I'm like, no. No, he sleeps all through the night. Like, oh, you're lucky. I'm like, well, this is our 4th child. We've been lucky 4 times. I think maybe it's not luck. Maybe there's something about working with natural systems. My understanding is when the baby gets its critical needs met, it sleeps and it poops and it nurses and gurgles at you a little bit and then sleeps some more. Crying is a sign of something being wrong. I would suggest a lot of our seedlings, a lot of our baby plants, when they don't get their colostrum, they don't establish good, healthy gut flora, is when they're likely to dampen off and have these other failure to thrive symptoms. So from a foundational standpoint, giving your baby plants their colostrum is a really, really simple process, and one which I think is not necessarily applied as much as it should be. It's really, really simple. I'll just give you an example. So, literally an ounce of an inoculant might cost you $5 or $8, and 1 ounce of inoculant is good for 50 pounds of seed. I'm talking like tomato seed and carrot seed and lettuce seed, right? 50 pounds of seed is a whole bunch. $8 to inoculate that much seed is a very, very small investment. You literally have to open the package and open the seed package, and you just take a pinch of inoculant and you put it in each package of seed. You close the package, you shake it up, and you've got those spores on the bacteria seeds, called spores, on the plant seeds. And they're in contact, and when those plant seeds are exposed to water and warmth and they germinate, guess what happens to the bacterial seeds and the fungal seeds? They all germinate, they are all born at the same time, and they set up that symbiosis at birth. It's really, really powerfully simple. Is that no, you're just scratching your head. People are familiar with the idea of adding bean and pea inoculant to their beans and peas, right? This sort of azotobacter and rhizobacter to help the legumes fix nitrogen. It's basically that exact process, except you want to get 50 or 60 different species of bacteria and fungi that are symbiotes with all of our crop plants to help establish gut flora. You don't need to buy inoculant. You can go out and harvest inoculant if you want. You can make your own from your local environment. I'm not saying you need to buy it, but understand the importance of inoculation. If you want to make your own inoculant, it's really simple. All you have to do is go for a walk with a bucket or a plastic bag. If you go for, I would suggest hitting as many microclimates as possible. So a field edge and a meadow and a swamp and a forest and a riverside, and you just look for plants that have shiny leaves. Plants that have shiny leaves are fat and happy, and you just gently go down to the earth and ask for a handful of soil underneath that plant. Any plant that's fat and happy, it's going to have good, healthy gut flora. So a handful of soil put underneath that plant is going to be having a broad spectrum of microbes in it. You take a handful of that soil and stick it in your bucket and keep walking. And you hit as many microclimates as possible. Handful of soil from here, handful of soil from there. When you get back home, put some water in that bucket, mix it all up, pour the water into a watering can, water it onto your seedlings, onto your seeds you just planted, and you basically harvested microbes from your environment, and you've applied them into your growing environment. If you want to establish gut flora on the leaf surface, the phytoplane, there's different microbes that live on the leaf surface than the ones that live in the soil. And you simply on your walk, you'd harvest shiny leaves and put them in your bucket. And when you get home, cover that with water and stir it up, squish them a little bit, put it into a backpack sprayer, and you can spray it on the leaves, right? You can buy inoculants, you can harvest inoculants. There's compost teas, there's dozens and dozens of different protocols, etc. But understand the critical importance of these other, kingdoms in the process of growing plants, I think, and please endeavor to address that. As with all these things that I'm saying, I like to say, I'm just some random guy from Massachusetts. You shouldn't trust me. If anything sounds intriguing, A, you can look it up. B, you can experiment, find a corner, try it out over here, and see if you get any kind of response. This has been my experience with the farmer, but yeah, just for general purposes of consumption of information. My last topic here is minerals. This is the one that I probably started off with in my experimentation process. I'd heard about this idea of minerals and their critical role in plant health, and I was like, well, I never heard anything about that. I might take a little bit of time on this topic. I think it's one that a lot of people have not been properly exposed to. So for starters, let me just say a couple of things about, just sort of frame the conversation. Anybody here ever been a vegetarian or a vegan? A couple people heard about this idea. I've been told that if you're a vegetarian or especially a vegan and you go to a doctor, they'll tell you that you should supplement your diet with vitamin B12. And that's because there's not enough vitamin B12 in your plant-based diet. And if you don't have enough B12, you become anemic, which means you're weak and you're lethargic and low energy. And if you really don't have enough B12, you become dead. That we are B12 dependent organisms. You need a certain amount in your body, and so supplementing is really critical if you're especially vegan. As I understand it, B12 is the common name for a compound referred to in science as a cyanocobalamin, which doesn't really matter except for the cobalt part in the middle. Refers to the fact that that B12 is one atom of cobalt, which is an element, surrounded by a few amino acids. And so the amino acids are not in short supply in the vegan or vegetarian diet. It's the cobalt. So we can say we are cobalt-dependent organisms. As I understand it, 80% plus or minus of the species of soil life that are known to exist are B12 dependent as well. Which means if you don't have sufficient cobalt in your soil, you're never going to have the spectrum of life in your soil that your plants need to function. You can apply all the compost tea you want. You can apply all the compost you want. You can apply all the nitrogen, potassium, and phosphorus you want in various forms. But if you don't address a cobalt deficiency, and you need a total of like 4 pounds of cobalt in an acre, right? It's not a hell of a lot. You're never going to have the spectrum of life in the soil that your plants need to function. I didn't talk about the molybdenum yet, but there's in the bean and pea inoculant that you may have used in the past to get the nitrogen fixation going on your legumes. There is I think in this country there's 1 million pounds of molybdenum sold every year mixed into bean and pea inoculants. You might not have even heard of molybdenum, but it's another element on the periodic table of elements like copper and zinc. And the reason that molybdenum is mixed into your bean and pea inoculant is because it is it's the center of what's called a nitrogenase enzyme, which is a compound that's used by the bacteria to pull nitrogen out of the atmosphere. If they don't have the nitrogenase enzyme, they can't actually do the job of harvesting the molybdenum. So, for whatever it's worth, the basic point here is that if you don't have the critical elements present, the critical minerals present in the soil, that inhibits the overall system function as well. So I can go into all these topics in much greater depth. I'm getting a sense that people have had enough of the general overview. Maybe it's too warm in here. I'm not quite sure. I'm seeing a little bit of yawning. Is something going to be modulated? Temperature? Yes.
To turn it down a little bit?
Yes. Yes? Okay. I generally like a little more interaction in the presentation. You guys are being kind of quiet.
I have a question.
Possible? Yes. We'll just stop for a minute.
This may be jumping way ahead, but when you were talking earlier about bugs and various other things attacking our
Yeah.
plants and that being a sign of poor health. So where we live here, we can plant fruit trees and survive, but it's very hard organically to get them to produce anything. Because of bugs, because of fungi and various things like that. So if we were able to create a healthy enough ecosystem,
Yeah.
would that be possible even in a climate that, I mean, everything I hear is that there are just too many bugs here, you can't do it.
Yeah. So now that we've covered the basic foundational points, we can have more interesting conversations like pest and disease resistance and flavor and aroma and nutrition and carbon sequestration and human health. There's all kinds of really interesting permutations once we understand the basic points. So let's talk about pest and disease resistance. Yeah. So for starters, conceptually, if we were stuck in a room together for an hour and a half and I was coughing and sniffling, it's entirely likely that you would all breathe in my germs by the time that our time together ended. Yes? And you also would probably agree that not everyone would get sick, even though they were in the presence of the germs? Yes?
Yes.
Right. So we can agree then that the presence of the pathogen does not determine whether you succumb to it. Right? This is germ theory is the general argument here. I think it was Louis Pasteur who proposed germ theory. That it was the germs that caused the disease or whatever. Pasteur had a contemporary named Beauchamp who said it's not the presence of the germ that determines whether you get sick or not. It's the biological terrain. It's basically your immune system function which determines whether you succumb or not. And so what I'd like to suggest is we understand that in us that the germs can be present and we don't get sick. Conceptually, that's basically the same case with our plants. So let me just give you a couple more examples. If there was a bale of hay here in the room when you walked in, would anyone have considered eating it? No, no one would have considered eating it. You might have considered sitting on it. If someone walked a cow into the door, you think she probably would not have considered sitting on it, but she might have considered eating it. This is all sort of rudimentary, obvious common sense. Why is it food for a cow and not food for us?
They can digest it, their gut can digest it.
Because they've got 4 stomachs and they can digest it, and we only have 1 stomach and we can't. We know this. We know that different organisms have different digestive system functions and capacities.
What, is it that their bacteria in their gut will digest it? We don't have that bacteria.
They've got the different stomachs have different environmental conditions. So this stomach has these people that do the first level of breakdown, and then it goes to the next stomach, which has different organisms in it, which is the next level of breakdown. So it's a multi-stage process basically, which allows them to break down things that we can't. And so I like to. So we understand that different organisms have different digestive system capacities. Well, the Colorado potato beetle larvae, as an example, or the what is it, Plumcoculio, as an example of a larvae. In general, larval forms of insects do not have a liver. They don't have the enzyme in their gut necessary to break down protein. And so this is the sort of the meta arguments for, which actually goes to the conversation about quality, is different organisms have different digestive system functions. And so I'll get to this in a second, but I'm going to stand back for a second and just sort of engage a different point. Has anybody ever bought a peach from the store and eaten it? Once, and then you stopped. You know what I'm talking about? That classic, like peach, like it's not really, it looks like a peach. They call it a peach, but you damn well know it's not a peach, and it doesn't taste like a peach.
And tomato.
And a tomato is another classic case. We were talking about carrots here earlier. Right, you've ever had those organic carrots from California, the Cal-Organic ones that we did this one time a couple of years ago. We made the mistake of selling all of our carrots, and we're like, oh, shoot, well, when we went to one of our customers, our local health food store, and we had ordered a 50-pound bag of carrots for the winter. And we opened the first bag and tasted the first 2 carrots, and the rest of them sat in the cooler and rotted because they were entirely different. So I think they say that something in the order of 30% of your DNA is associated with the function of your nose and your tongue. Nature seems to think it's really important that you're able to smell and taste well. They're actually very, very sophisticated nutrient monitoring devices. And what makes there's the compounds that make a carrot have a carroty flavor, and the tomato have a tomatoey flavor, and the peach have a peachy flavor, etc. Those compounds, those aromatic compounds, are called plant secondary metabolites. They're terpenoids and alkaloids and phenolics, and they've got all these fancy names. But they're basically really big, complicated compounds in a plant. There's thousands of elements in one of them. And for the plant to build one of the plant secondary metabolites, they first have to build the component pieces, right? To build the 5,000 element compound, you first need 1,000 element compounds. And before you have the 1,000 element compounds, you've got the 500 element compounds. So they get screwed together. That roughly makes sense. So the 5,000 element compounds are the secondary metabolites. The 1,000 element compounds are the fats and oils. The 500 element compounds are the proteins. So the simple compounds you start off with are sugars, and then you complex the sugars to make carbohydrates, and then you complex the carbohydrates to make proteins. This is not exactly the way it works, but effectively. And then the proteins are used to make lipids, fats, and oils, and finally you make those compounds that correlate with flavor and aroma for us. And basically, the insects, the larval forms of insects, can't digest protein. So when your plant is building compounds on the way to building flavor, it becomes indigestible in the same way a bale of hay is indigestible for us. So, I grew up on an organic farm where we, my parents planted an orchard when I was a kid, and for 20 years they didn't get any fruit. And then about 5 or 6 years ago they started doing some of this stuff, and they've been having, what's the word? Bumper crops. Bumper crops of fruit on their fruit trees. And we used to have this curculio that would cause the plums to all fall and everything else. And I mean, it's not the case anymore. And certainly we're told in New England that it's too wet, the fungal pressure can't be stopped, et cetera, et cetera. So my understanding is that the fungi have a certain sort of digestive system capacity, and when you have fungi eating your plants, that's nature telling you that your plants are fungus food. That when you've got larvae who have a certain digestive capacity eating your plants, that's nature telling you you're growing larvae food. When you've got beetles eating your plants, that's nature telling you you've got beetle food. And only when you've got animals eating your plants are you growing animal food. It's very simple, and I'm not sure if I made the point very well, but on my farm, I have a philosophical position, which is I will refuse to kill an insect or a disease. If I have, Colorado potato beetles eating a potato plant, I will let them eat that potato plant, because if it's food for an insect, it's not food for a human. I would consider it to be unethical to, try to kill the insects in order to produce a crop. This is a mind shifter, perhaps, for some people. And I don't feel like I'm conveying it as well as I sometimes do. But the basic answer is, based on the digestive system capacity of the pathogen, that will tell you basically how functionally healthy the plant is. Long answer to a simple question. It's somewhat coherent. Are there other questions here?
Well,
Yes.
when you first started tonight, you said that you would take your 5-gallon bucket and knock potato bugs into it.
Yeah.
And then what? You said
And then you dump them
weren't
into the fire or down the toilet. What do you mean? And then
Well,
what?
you said you just weren't going to kill the bugs. That you considered.
This was 12 years ago.
Oh, okay.
And this was sort of my childhood experience of growing up on a farm is that the flea beetles ate all the brassicas, the potato bugs ate all the potatoes and the tomatoes and the eggplants, and the blights took out the cucumbers and the squashes, and we had failure to thrive of our crops, and we thought we were just suffering, and that made us better people, and we're organic farmers, so we're better people. And conventional ag, in many cases, they've got some pretty sophisticated chemical weapons that are used to kill these insects and fungi. And I mean, the broader argument is that when a plant is not getting into it the nutrients that it needs to build these complicated compounds, it functionally does not have the nutrients in it that our bodies need. And so this is the sort of the larger conversation about human health that I think is worth engaging. I can use the sort of metaphor or the topic of a greenhouse to maybe convey this point. Everybody's used to a greenhouse or knows what a greenhouse is. I have a number of greenhouses, as I said, and I built a bunch of them. And when you start to build a hoop house, for those who have had the experience of building a hoop house, you start off with a pile of metal pipes that's not particularly large. Maybe it's 10 or 12 feet long and a couple feet wide and a couple feet tall. And by the time you get done building that hoop house, you've got a structure that's 100 feet long and 15 feet tall and 30 feet wide. And the only thing you've done to build that hoop house is you have used a 9/16 socket and wrench and a 1/2 inch socket and wrench over and over again. Have we done this before? To build a hoop house, right? You just screw the nut onto the bolt to put this piece together, and then this piece together, and this piece together, over and over again. The metaphor here is that that socket or wrench in a mechanical system is like an enzyme in a biological system. They say when you're complexing sugars to make a carbohydrate, you are using it. Life uses enzymes. There's an enzyme is what is used to screw the sugars together to build a carbohydrate, in the same way that the socket is used to screw the nuts together to put the hoop house together. When you're building a protein, you take amino acids and you screw them together over and over again, and it's the enzyme that is used to screw the amino acids together. And when you eat that protein, when you have a burger and you digest it, the life in your gut uses the same exact enzyme to unscrew the protein into its component amino acids. So what makes the enzyme function in its unique manner is its size and shape. Just like a socket or a wrench or a screwdriver or an Allen wrench, every one has its unique size and shape and it's used over and over again. So what's at the core of an enzyme that gives its unique size and shape is an element. There's there's copper-based enzymes and zinc-based enzymes and chromium-based enzymes, etc. So copper as an element maybe has a size like it's 1.5 angstroms across, and it's got a bonding geometry that's 6-sided, and zinc will be like 1.6 angstroms across and have an 8-sided bonding geometry. It doesn't really matter. What matters is that each enzyme has its unique functional capacity based on the element at its core. I like to say that if you were a car and your brake pads wore out, they're designed to be taken out and new brake pads put back in. If your muffler wears out, that's designed to be taken out and a new muffler is designed to be put in there. And that's a mechanical system, but we are not mechanical systems, we're biological systems. We're not designed to have our parts taken out and replaced. We're designed to be constantly rebuilding our bodies. Anybody know about this? You get 4 billion new cells every day. Every day your body takes roughly 4 billion of its oldest, junkiest cells, disassembles them, chucks the parts that can't be used anymore, and builds 4 billion new cells in their place. They say on average you get a new body every 6 months. You heard this one? Yeah. Your bones take 7 years to replace themselves. Your blood takes 2 weeks to replace itself. But on average, you get a new body every 6 months. Every single day, your eyeballs, your gonads, your liver, your flesh, everything is being constantly rebuilt. When the Human Genome Project was being performed and they were mapping out all the DNA in the human body, they didn't just map out all the DNA, they also identified all the enzymes necessary to replicate the DNA. And when they identified all the enzymes, they were able to identify all the elements because every enzyme has an element at its core. And the upshot is you need dozens of different elements to replicate every strand of human DNA. So inside every cell is a nucleus, inside every nucleus is DNA. 4 billion times a day, you need dozens of elements just for basic bodily maintenance. This is nothing radical. This is just a bunch of the facts that we already know put together. So my first question is, when you take your soil test from Virginia Tech, how many elements do they recommend you manage for in your soil? Generally it's 3, right? I mean, Cornell is 3, and UMass is 3, and Iowa State is 3, right? If our bodies need dozens of elements for basic function, and our fertility programs recommend 3 elements, maybe there's a problem here somewhere, right? Maybe the purpose of growing crops is not volume and aesthetic. Maybe there's a connection to that natural, intuitive, flavor and aroma sense. Companies have gotten really good at synthesizing flavor compounds and putting them in functionally empty food and causing us to want them, right? There's a really good book called The Dorito Effect, which names and lays this whole process out. It's brilliant. Industry has understood that we as animals are looking for these compounds, not because we're looking for those compounds, but because in nature you only have those compounds in the presence of a whole broad suite of other nutrients. And when our food doesn't have those nutrients in it, functionally, so as an example, in one of those 4 billion cells, if you don't have chromium when the DNA is being replicated, then you don't have the chromium-based enzyme. If you don't have the chromium-based enzyme, then the piece of DNA that's supposed to get put together by the chromium-based enzyme doesn't get put together. That's called a genetic marker. It's a break in the DNA. It's called a genetic marker, right? We know, we've tracked the associations between genetic markers and degenerative diseases. Heart disease, cancer, osteoporosis, et cetera, et cetera, et cetera, et cetera, et cetera. We know about the epidemic levels of degenerative disease that are present now that were not present 80 years ago. The USDA has mapped nutrient levels in crops since the 30s, average nutrient levels in crops, and this is the trajectory. We also have data on the epidemic levels of degenerative diseases in the human population, and it goes like this. There's a beautiful. It's like, huh.
Cause and effect.
Well, we can't say for sure.
Correlation.
And there's just a correlation. There's just a correlation.
Nice picture.
Yeah, it really looks pretty close. So, what's exciting as far as I'm concerned, we can see that the chromium deficiency correlates with the symptoms and the markers for diabetes, is that if you add chromium to someone's diet, and their body's constantly rebuilding themselves. Next time that cell replicates, next time that DNA replicates, if the chromium-based enzyme is present, that piece of DNA that was broken gets fixed, right? It's not like it's just broken, it's just that they didn't have the 7/16 for the, 5/30 seconds. They needed that one 5/30 seconds, they didn't have it. Well, it's okay. The thing will hold together. It's not perfect. Anybody ever? Don't really need the 5/30 seconds very often. So, I mean, from my perspective, this is where it gets really exciting. So if anybody's concerned about the, the human health, was there Hippocrates somewhere around here? I thought I saw Hippocrates quoted somewhere in this room. Maybe it was outside. People know who Hippocrates was? They referred to that when medical doctors, finally finished their 18 years of schooling, they swear the Hippocratic Oath. You know the Hippocratic Oath?
Do no harm.
First, do no harm. Then,
Do no harm.
do no harm. We could say no cutting, slicing, burning. That's no harm, right? No. First, do no harm. Great. Foundationally, don't screw things up too badly. Then,
Very good at medicine.
let food be thy medicine. Heard that one? Let food be thy medicine. And then finally, let me never be conned, tricked, or bought off into prescribing a poison. This is the third part that they really don't want to talk about. First, do no harm. Then, let food be thy medicine. And finally, never let me be conned, tricked, or bought off into prescribing a poison. This is how many thousand years old? I would suggest that if anybody's concerned about the federal debt, the trajectories that we're mapping are that it's not the debt that's going to bankrupt the country, it's not the military expenditures that's going to bankrupt the country, it's healthcare costs that are going to bankrupt the country. In Massachusetts, I know that 40% of the state budget goes towards healthcare. 40%. I suggest that we as farmers have a responsibility to solve this problem. And we can certainly work with consumers to help them understand the connection between flavor and health. Yes?
What did you do differently from before when you had lots of mosquito beetles versus now?
I kept my soil covered. I kept my soil wet. When I grew up on a farm, my parents' farm, my mother was like very proud to say that we're organic farmers. We don't need to irrigate. I was like, except when the soil's dry. I like to put mulch down after I plant because, among other things, it doesn't just feed the soil; it also keeps the weeds down. Anybody ever weeded in the summertime? I mean, I spent lots of hours as a child weeding like carrot. Anyone weeded carrots before? Right?
Here we have winter weeds.
You like pull out the trees and you leave the like the little understory, right? So yeah, for starters, keep the soil covered. A foundational point. Keep the soil moist. Take a soil test. I can pretty much guarantee that everybody in this room, if they haven't added sulfur or boron in the past couple of years, can pretty much guarantee deficiencies. 50 pounds of elemental sulfur per acre is like a massive dose. Awesome. Fill that tank right away. 50 pounds per acre. That's not a hell of a lot. Ever heard of borax? 30 pounds of borax per acre. Massive systemic jiggering of the boron levels in the soil. Boron facilitates calcium availability, calcium facilitates silica availability. All these things are beautifully intertwined. I personally on my farm don't use compost. I don't use blood meal, I don't use fish, I don't use nitrogen sources whatsoever because I'm of the opinion that for a very long period of time, no plants in nature were being fed nitrogen and they're doing just fine. There was a Russian microbiologist who, by the mid-70s, had identified more than 2,000 species of nitrogen-fixing bacteria and fungi that were symbiotes with every single family of crop plants. We have this idea that only legumes can fix nitrogen functionally. That's wrong. Yes, legumes can fix nitrogen. Yes, legumes have these little nodules, but tomatoes can fix nitrogen, and corn can fix nitrogen, and oak trees can fix nitrogen in symbiotic relationship with bacteria and fungi. Nature figured out the way. 3/4 of the atmosphere is nitrogen. 1 pound of molybdenum per acre at the center of the nitrogenase enzyme is all you need to no longer need nitrogen fertilizer. Anybody got a problem with the Farm Bill? You got a problem with agribusiness? Anybody? No. No. I suggest that the reason the Farm Bill is the way it is because agribusiness has lots of money to buy senators and hire lobbyists to write the Farm Bill. Am I off with politics? Okay. In this room?
Yes,
Yep. All right. So, I suggest the way we solve this problem is by sucking the life force out of agribusiness. I suggest that if farmers didn't need fertilizer, then they wouldn't be giving the money for fertilizer to agribusiness. I suggest if farmers had functioning biological ecosystems, they wouldn't need nitrogen fertilizer. Right? Phosphorus, triple superphosphate, which is polluting the aquifers and causing dead zones in the oceans. Right? If you've got mycorrhizal fungi in the soil, they will solubilize and feed your plants all the phosphorus they can possibly need. Only when you till the soil and kill the soil do you need to add phosphorus. Right? The basic practices we engage in are the reasons why the system is broken. And if you have healthy plants, if you have plants that have strong cell walls that are producing these secondary metabolites, they're physiologically indigestible to fungus. Insects can't eat them. It's like us eating a bale of hay. Well, if that's the case, then you don't need fungicides. Then you don't need insecticides. If farmers didn't need fungicides, if they didn't need insecticides, if they didn't need triple superphosphate, if they didn't need urea, then agribusiness wouldn't have money. Then they wouldn't have the money to buy senators and to write the Farm Bill. I mean, we are all responsible for the Farm Bill being the way it is because we are buying the products of agribusiness, as far as I'm concerned. So this is where we can talk about systemic solutions and where do the consumers come in and drivers. I spent my 20s, a lot of my 20s, I would work on Parents Farm in the summertime and then go be an activist here or there doing all kinds of different things in the wintertime. And I, at that point in my life had this idea that if we just spoke truth loud enough, people would change their actions. And I have maybe become a little more cynical about life since then. There's this thing called the Maslow's hierarchy of needs. Anybody heard of Maslow's hierarchy of needs? So we know that the climate is, becoming awry. That there's symptoms of serious problems with carbon in the atmosphere, and everybody's saying, well, you just stop driving your car, and that'll solve the problem. And we're like, yeah, I should stop driving the car, but I need to go to work, and the only way I can get to work is by driving the car. So I'm going to keep driving the car because I need to pay for my families. I need to keep my children fed. The greater good is nice, but when what's in the greater good gets in the way of survival of my family, I'm going to choose survival of my family every single time. That's what basically Maslow's hierarchy of needs says. And so for me, the question is there some way where we can connect people's rudimentary self-interest, some foundational need with solutions? And I suggest that there is, and it's kind of exciting. Before I talk about the consumer side, exactly, let me just talk about the climate piece, because I think I referred to it a couple of times without talking about it directly. When you're taking carbon dioxide and turning it into sugar, and you're putting the sugar into the soil, functionally you're taking carbon out of the atmosphere and putting it into the soil. Yeah, everyone's okay with that? When you are growing healthy plants, and this has been documented in multiple continents on big farms, like 5,000 acre farm here, 20,000 acre farm there, you can increase soil organic matter levels by 0.5% per year. 0.5%. So 1.5 to 2, 2 to 2.5, 2.5 to 3, year after year after year. We've got farms, big farms, that are not adding compost, that are not mulching, they're doing this year after year, from 1% to 10%, right? Decades in a row. If you do the math on how many acres of agricultural land there are on this planet, and how much carbon is in 0.5% of organic matter, it is really easy to go from 400 to 385, 15 parts per million CO2 sequestered into the soil in 1 year. Right? 385 to 370 in year 2, 370 to 355 in year 3. I read this article by Bill McKibben of 350.org yesterday. people know Bill McKibben? You good to that work? Then we'll do climate activist from Vermont. He basically, wrote this letter to the editor in his local newspaper and said, we're screwed. We missed it. It's too late. It's all over. Can't do it. Because all the climate activists are focusing on stopping using hydrocarbons. And he said the trajectory, the political likelihood of us stopping using hydrocarbons in the next 4 years based on the political dynamics is very low, and we're already close to the edge, and we need to stop using hydrocarbons by 2030, so I think we're screwed. And my pushback to that, my pushback to the whole climate conversation is at least 40% of the carbon that's in the atmosphere that's been added since 1750 came from the soil. At least 40% of it came from the soil. The process of tilling soil and exposing soil to sunlight causes it to oxidize, causes the organic matter to turn into carbon dioxide, right? So this is like the elephant in the room, and what's really exciting is it came from the soil and it can go back into the soil, right? We can build soil really rapidly. I suggest we can deal with the problem of human health. I suggest we can deal with the problem of agribusiness and the environment. I suggest we can deal with the problem of the global warming issues through an economic driver around food quality. I suggest if consumers were to choose the healthiest bag of carrots, the most flavorful bag of carrots, and the only way to grow those carrots with nutrition is to have a well-functioning biological ecosystem. If we could do that one thing, we could instill the economic drivers. And I think what I've come to in my 30s is that money is power. That good ideas are nice, but that money is power. And if we can align good ideas with money, then we can get somewhere. I suggest, people coming in and out of the store all day long are buying food with money. If the people who bought food had the capacity to choose the most flavorful bag of carrots off the shelf, that could be an economic driver which would actually turn a lot of these things around. So that's one of the projects our organization is working on, is a little handheld gizmo. Not because gizmos are great or anywhere near as good as your tongue, but because lots of people like to use gizmos, right? We've got them all, like these little tools, these little screens and things. So the idea here is basically a screen that you can have in your hand, pull out of your back pocket and go, burp, grab, decent. That's it. And version 2.0 or 3.0 could be just an app on your smartphone, but until your smartphone has the right sensor, it's not going to work. It has to be a standalone gizmo. But functionally organizing around the question of nutrition in crops, flavor and aroma and health-giving attribute, as opposed to all the labeling certifications, like I'm organic, I'm local, I'm biodynamic, I'm permaculture, I'm a good person, you're bad people. Like, it's all process, it's not flavor, it's not aroma, it's not nutrition. And so that's our organizational endeavor, yes.
So, knowing I'm not a farmer, I'm here more from the other aspect of the consumer standpoint.
Yes.
So if there was something today, knowing that that little tool is available, that
Yeah.
that I could do or that I could share with others to do to not only help myself to get food that's more flavorful, full, and better nutrients, but also to help reinforce the need for that, what would be the actions that I could take, both personally and to help further the cause of all our food should be better?
The best tool we have now is called a refractometer. And it's really old. It's like 180, 190 years old. There's no batteries involved. It measures refraction of light, the bending of light. So when you stick your hand in a bathtub full of water, it appears to bend. It's not because your hand bent, it's because the light bent when it passes through water. If you stick your hand in a bathtub full of salt water, it'll appear to bend more. And it's only because the salt in the water causes the light to bend more. And so all a refractometer does is measure the bending of light. But do you have a refractometer here?
No, maybe drive
I
it.
told you we didn't need it, and that's why you didn't bring it in.
Yeah.
Yes. You can bring it in, sure, thank you. A refractometer, basically you can take garlic press and take it. The problem with refractometers, you need to get a drop of juice out of the crop to get a reading. So that would mean going into the grocery store and taking a chunk out of an apple to get a reading and saying, oh, crap, that was crap too, that was crap too. So what you have to do is you have to buy the crop first and then test it and then, have some way of putting it up online and telling other people about it.
Are there websites that are doing that?
No.
So there's
not practical.
So there's nothing you can, as a consumer, to help, not, again, not only check your own food supply, but also to say, I want my farmers to be using these mechanisms, and I'm gonna support that, but do you
The
go
problem
to-
is that you're on the cutting edge. By being, if
Gotcha.
you heard me in 3 years, I would say, you know, we can do this, this, and this. When I came across these ideas, I don't know how many years ago now it was, 6 or 8 years ago, I was like, wait a minute. Wait a minute. How come nobody's talking about this stuff? Because it all kind of makes a lot of sense. And it was like, yeah, well, nobody's talking about it. So,
But she can use her tongue in her nose.
you can use your tongue in your nose. Yes.
I was just gonna respond to what you were saying and the fact that it's really frustrating, but I think the only really immediate, somewhat practical thing that you can do is to talk to local farmers and see if they're doing these things, and the chances of what they're producing being what you want are higher. And that is taking it a few more steps further than most people might be willing to go, but if you are willing to do that, then that might help you.
The problem is that a lot of farmers are struggling as it is, and they're like, one more consumer on one more fad, giving me a hard time. You know, if you don't frame it gently, they're just gonna get pissed off.
Yes.
So, our work, you know, organizationally, we've said, before we talk to the consumers, we're not even gonna talk to the consumers, because they're just gonna get worked up. And when there's no answer, what we have to do is we have to work with the farmers to help them do better, so that when we get around to talking to the consumers, we can say, here's the farmers you can go talk to.
Yeah, exactly.
You know, at this point, you know, I think we're 7 years old as an organization. We've got chapters in like 15 different states. It's all been sort of percolating along in a very grassroots manner. I've been envisioning this tool thing for a long time. Once I understood enough about the physics of what was possible with spectroscopy, I'm like, wait a minute. We could actually develop a tool that could test quality. We could flash a light at crops. And I started to go talk to the physicists and engineers, and they're like, yeah. I'm like, well, how come nobody's doing it? Well, you know, they haven't had the idea that we could even do that. But for starters, we don't even have a definition of quality. An empirical definition of quality. What are the mineral levels and ratios that correlate with a high quality carrot and a low quality carrot? Nobody's done the research. Nobody's done the research. All we have is USDA averages. It is like this big elephant in the room that if you put the pieces together, it's like if we could just, that this should be our next human genome project. This should be our national microbiome project, is what is quality and what causes it? What are the environmental conditions that are causal? We think we have a pretty good idea, but until you can publish it in the literature, until you can go and do proper science and say, here's the documents, you know, it's, my suggestion is if we do it empirically, we can hide behind the science and go very far, very, very well. The problem with the science of quality is it's multi-factor. And most science that's done is a single factor analysis. What's this much copper versus this much copper, what's the effect? That's how PhDs are done. That's how science is done. Mostly is single factor analysis, which is good for a reductionist paradigm, but it's not good for a biological paradigm. So there's a whole shift in understanding involved here. But we're finally in a place now organizationally where the cost of manufacture of these tools has come down to, like, I can guarantee you it'll only cost $80 to build one of these things. So, like, that wasn't the case 3 years ago. With the miniaturization of technology, you know, we are now at a point where it's plausible to have something at a consumer price point that can give you the parts per million concentration ranges. So, anybody who wants to help, you know, our organization is working to do this. I'm waiting for somebody else to come out and compete with us in the space, but there's like nobody out there. It's like,
What she can do is write a check.
yes. Money is always welcome. I've done a really bad job of raising money in the past. Our social media presence is basically zilch. We've been doing a lot of good grassroots work with growers around the country and not much else. So I think the time is coming. Organizationally, in the past 6 months, we have basically shifted into a new gear of like, okay, we're ready, we are established, we're going to do this. So I'm in the process of raising that money and organizing that research project and developing the tool now. But it's going to be a couple more years until we got something. Yeah.
Can I just add a
Please.
to the chapter, because you know part of the chapter is getting together, talking about it. You don't have to be a farmer, you can be a gardener, you can be a consumer, and be part of the conversation, which I think is really helpful.
Yeah.
And then the other thing too is to start a garden and
That's the idea, is if it's true, if all the stuff that I'm saying is true, it'll work.
Yeah.
And if it works, it'll spread. And I think the only real things that change things come from the grassroots. It comes from people on the ground, getting the results, talking to their friends. It's not media, it's not surface, it's not marketing, it's not labels, it's not multinationals, it's none of that stuff. It's like real from the bottom work. So, sorry,
Thank you.
not easy, yeah. Yes. Yeah, let's hand that one out. Yes.
I'm really, it's great, I love hearing about soil biology and how you can actually use the farm ecosystem to create plants that are against the pests can get. I wonder
Yeah.
if you have any practical applications of how we can help create this ecosystem, keep pests away from our soil, really healthy. Like the seed inoculant, but if you have anything else that you can leave us with nuggets of.
It's really like in every situation you say, are these things present? Is there any one of these things that's not present? And if there is, work to address it. I mean, there's no like silver bullet. It's just common sense. Can I reach my hand into the soil? No. It's too tight. There's no air. Can I feel moisture in the soil? No. It's too dry. Can I see the soil? Yes. There's not enough cover. You know, the one thing that you can't do, like unless you know how to read plants and say these plants are all telling me calcium deficiency. Until you know how to read the plants, a soil test. You know, and I specifically suggest that you don't go to Virginia Tech. You do work with an Albrecht style lab, which is one that's coming from a more holistic sort of perspective, and will give you numbers on 15 or 18 different elements. And that's part of what I'm doing in the 2-day course, is teaching people how to read a soil test. It's like, you shouldn't need to go to somebody and like put your faith in their perspective. This is all empirical, and we can figure it out, and it doesn't take that long to understand. There's books you can read. You don't need to go to the course. I can tell you what the books are, how to read a soil test. I didn't talk about the minerals piece as much as I'd like to, or as often I do. But from a systemic standpoint, a lot of our soils on this planet are weathered at this point. Agriculture has successfully denuded our soils of a lot of the critical elements needed for life to flourish. And between finely ground rock dust and seawater, which the earth is made out of, basically, right? The continents are made out of rock, and the oceans are made out of seawater. Between those two ingredients, we have all the elements necessary to revitalize the planet. So, we could talk about the nuances and details. Probably there's not enough time here, but going to a local quarry where a byproduct of the quarrying industry is finely ground rock dust, and it's available generally for like $2 a ton or $4 a ton, and just spreading that onto your land is a systemic remineralization. But yeah, if you can maintain these basic environmental conditions, I think from a foundational standpoint, that's a lot of improvement. I don't think I talked about corn here today. What's that? 25 minutes? Okay. You're telling me I should slow down?
I'm telling you, you have time.
I got time. Just a second. There's this thing called yield potential. If you go to the universities and you talk to the geneticists, the corn geneticists at Purdue or at Iowa State will tell you that the yield potential of corn in this country, according to the genetics, according to how the plant grows, what is possible is something in the order of 1,000 to 1,200 bushels per acre. The average yield of corn in this country is about 160 bushels per acre. If you do the math on what percent of the yield is being realized on average, it's somewhere between 10 and 15%. So, anybody go to college here? You ever get a final grade in a course that was between 10 and 15?
Yeah.
Got 35. This is about as low as I got. And I got a D because it was organic chemistry, and everybody else got 20s and 30s and 40s. Yeah. My point is, perfection is like not even to be considered or worried about. If you can begin to address some of these deficiencies somewhat, my experience as a farmer is that your yields will increase dramatically, your plant health will increase dramatically, And if you're intellectually honest with yourself, you'll tell yourself that I'm nowhere close to where perfection is, but it's relatively dramatically better than your neighbors. So on my farm, I might be realizing 30% of the yield potential of my crops, which looks like I'm doing amazingly better than everybody else because I'm tripling their yields. But I'm still only getting a 30 out of 100. So it's a continuum, basically. The process is a continuum of understanding. And I think one of the people I first learned from, one of his aphorisms was, the biggest problem in applying these principles is between the ears, right? The biggest problem is our understanding of what's going on. And if you have somebody who knows what they're doing, and they come to your land and they say, do this, 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 and this, and you follow their directions directly, you'll have amazing results. But the biggest problem that people have generally is like understanding what they're up to. I'm not sure if I answered your question directly, but yes, you had something you had to say?
I forgot what I was going to ask.
Oh.
Sorry.
Yes.
So if you were applying something like rock dust or
Yeah.
something to your soil,
Yeah.
you're clearly not going to dig that in.
No.
So you're just going to put that on the top.
I just broadcast it.
You just broadcast it, and you
Yeah.
don't add any compost or anything.
Correct.
Doesn't that help? Doesn't compost help with like that all the microorganisms and things that are in the soil? Like, can't that?
I'm not saying compost is a bad thing.
Yeah.
I find it to be unnecessary.
But
And
you do use compost tea.
No.
But
Well,
how do you
when we're talking
increase
about
it?
with the inoculates.
I
That's kind of
take
like
1 ounce of spores
Uh-huh.
that
But
is
we're-
not made from compost. It's like it's straight spores.
Well, let's say like, you're saying they walk around to different
Yeah.
environments and pick, plants
Sure.
that look nice and get a little bit of soil from there, and a little bit of soil from here, and put that all together. That's kind of like compost tea, and spray that over top. That's the inoculant essentially.
Well, so I would call it inoculation, and compost tea is specifically something
Yeah.
that came from compost.
Uh-huh.
Going out and harvesting stuff is called IMOs, indigenous microorganisms.
Okay.
Inoculants are these little like spores in a jar.
Okay.
So there's different technical terms. It doesn't really
Yeah.
matter. So
I'm just trying to wrap my head around what exactly.
yeah, so compost is generally, besides an NPK source, a good biological inoculant.
See, that's kind of what I think of it, just from where I'm.
But oftentimes people will say, okay, I need so many pounds of nitrogen, and therefore I need so many pounds of compost.
Okay.
And there's lots of farmers who are like, putting down 30 or 40 or 50 tons of compost per acre per year.
Mm-hmm.
And they're saying, this is the model for sustainable ag, for no-till farming. And I'm like, and all those people in India who, don't have, any organic matter to rub between their fingers, like, we need a model for the planet that is plausible for revitalizing. And I suggest that there's a lot of stuff that is used and recommended which is unnecessary. We don't need bone meal, we don't need blood meal, we don't need feather meal, we don't need liquid fish, we don't need composted chicken manure, we don't need any of this stuff.
That's
Right.
all byproduct stuff to get
What's
rid
that?
of. I said that's all byproduct stuff to get rid of from those industries.
And it's actually pretty toxic, right?
Yeah.
I mean, the chickens that are eating GMO grain with glyphosate are pooping out the chicken manure that's composted and called organic fertilizer. It's still got the glyphosate in it. The chickens that are eating, or the cows that are eating the hormones, it's their blood from the slaughterhouse that is the blood meal's made out of, right? It's not organic cow blood. The bones, right, I mean the whole thing, these are industrial byproducts that someone has got an incentive to sell to you, and so they market it to you, and you think it's an organic fertilizer, and you spend money on it, and you short circuit the biological process. The plant has no need for that stuff if it's got the environmental conditions appropriate. It can harvest its own nitrogen. It can harvest its own phosphorus. So my suggestion is that we understand that we're doing a lot of things that are unnecessary, in some cases counterproductive, and in many cases costing us more money than they need to cost us. And in almost all cases, not really systemically addressing the problem. When you add fertilizer to the soil, fertilizer is soluble. Soluble is, it's like Gatorade or an IV drip, right? If it's got a number on the bag, it's soluble. Soluble means that the gut is not needed to digest it, right? An IV drip goes straight into the bloodstream. So you can be kept alive on a bloodstream, on an IV drip, right? You know about this?
Mm-hmm.
Right? That's not how you evolve to eat. You can be kept alive that way, but that's not how you evolve to eat. So anything that's got a number on it means it's soluble. 534, 10, 10, 10, 0, 52, 0, they all mean soluble. When you are putting soluble things into the soil, they're going straight into the plant's bloodstream. The digestive system is atrophies. The plant no longer takes carbon out of the atmosphere and puts it into the soil. because it's getting its nutrients from a different way, but it's not getting a full nutritional profile, so it becomes susceptible to infestation and disease, which is then why you need your pyganic or your, glyphosate or whatever else it is. Whether it's an organic fungicide or a chemical fungicide, an organic, insecticide or a conventional insecticide, the need for that is symptomatic of a dysfunctional system, which doesn't, I'm sorry, I'm going on a rant, but
No.
yes. So
Good rant.
compost is my point. So your point was about compost,
Yeah.
and I would suggest that I keep my soil covered.
Uh-huh.
And my experience is when I have my soil covered and moist and a few other things, that my earthworm population skyrockets. There's this thing called earthworm, boxes. People do this. They have a box and they make earthworms. You've heard about this?
Yes.
I've got a garden where my earthworms take care. I don't need to haul stuff here. I don't need to pull stuff out of the garden to make the compost pile, to turn it over, to haul it back. Right? Nature just drops stuff and digests it in situ. So I keep my soil covered, and when I go out at night with a flashlight, I see an orgy of earthworms going on. Anybody ever seen that before?
Yeah.
It's a beautiful sight. It's like once you get over not being invited, you're like, they're really enjoying themselves. Right. 18 earthworms per square yard, I believe, will give you 40,000 pounds of earthworm castings per acre. That's 20 tons. That's 1 pound per square foot. Anybody ever bought earthworm castings? What would it cost to buy earthworm castings at the rate of 1 pound per square foot for an acre? How many dollars per acre would that cost you? Right? How much work is it to buy 20 tons of compost and spread it? A lot of work. How much money is involved? How much work is it to make it? Right? You don't need to do any of that if you just keep your soil covered. If you just keep your soil covered, nature will do all the work for you. And my suggestion is that if we understand how nature works and we can support her, we can use much less effort to get much better results. And the net effect is we spend less money supporting the problem. Right? If farmers weren't putting the money into the chemical supply chain, the chemical supply chain wouldn't have money to control the farmers. But we need to figure out how to break the cycle, and I suggest it's the consumers that have the capacity to break the cycle. And the problem is we don't have a definition of quality. And so this is something we've been identifying organizationally for years. Is like, can we all work on quality together? Can we stop fighting GMOs? Can we stop fighting this? Anybody been worked up about fighting things recently? Do you know about the mind and the power of the mind? And where you put your energy is where your energy goes. Anybody heard this one before? You are responsible for the problem if you are putting energy into fighting, right? Until you take responsibility for your energy and you put it towards solutions, you are responsible for the problem, right? You get a real emotional high. I am justifiably angry. I am righteously indignant. But you're not solving the problem. You're just getting an emotional trip. Sorry. A little bit of a peeve of mine. Like, there have been so many things wrong for the past 8 years, and everybody's been sitting on their damn asses. Sure, things are wrong. They've been wrong for a while. Fighting them is not going to be the problem. What is the systemic solution? How can we focus our energy to create the reality we want to see? I suggest coming together. I suggest there's a need for a movement, a proper social movement. I suggest that there's this amazing opportunity with the food movement, with the environmentalists and the nutritionists and the agronomists, the universities, the farmers. I mean, I don't think there's any reason why we wouldn't want nutrition in our food. I don't think there's anybody who's doing a good job, so we can all learn from each other. Right? Anyway, that's my rant. All right.
What kind of mulch do you use?
Whatever's most readily available and least expensive.
So where
On my case, it's oftentimes mulch hay, which when the farmers cuts the hay and it rains before they get it baled, then it's not fit for fodder anymore, and they'll get rid of it for not
so
very
it's
much money.
green then?
What's that?
It's green mulch.
No, they after it rains, then they have to rake it a couple more times, but it loses its nutritional value, so they bale it, and they'll give it to me for $1 a bale or $2 a
Is it
bale.
organic?
So it's rotten mulch. I rotted.
But it's not rotted exactly. It's kind of rotted. Yeah, so, I mean, but if you're in the city, you ever heard about this thing people do where they pick up the mulch and they put it in bags and they put it out in the street? Yeah.
You can go to the dump.
You just
and get-
drive right, you can go to the dump, you can bring a car, you can bring a truck, you can bring a trailer. Like, there's, where I come from, we've got trees on the side of the street, and sometimes the trees grow in the way of the power lines, and the trucks come and they cut down the trees and they chip them all up. And a 6-pack or a couple pounds of ground beef can be easily converted into 10 yards of fresh wood chips. If you live close to the ocean, you can use, kelp, seaweed. I don't really particularly care. What does nature do? Nature drops organic matter on the surface. So, I mean, if you have a soil that's like in rough shape and not digesting well, then probably fresh wood chips would be a good idea. But other than that, whatever you can easily get your hands on, I would say, if it's going to go somewhere else and nobody's going to appreciate it and use it properly, why not utilize those local resources? Yes.
So,
The hay mulch bales, now, I
Yeah.
just started doing that, but I don't know if I'm doing it accurately.
Yeah.
Do you just pull sections of the bales apart and put it directly on the ground, or do you break it up?
I kind of give it a decent shake,
And how deep?
decently deep. When you're cooking, do you cook?
Yeah.
How much salt do you put in the soup?
As much as possible.
Yeah. You avoid it? All right, you're not a good example then.
No, I just wondered about the hay.
There's this thing called intuition.
Uh-huh.
And, I've been talking a lot of science and technical details, which is, a bit of a smokescreen, because that's not really where the answers are as far as I'm concerned. The answers are really in the, in the feel of it. And, indigenous communities around the planet were doing a pretty damn good job taking care of things with no science and no meters and no metrics, because they were in tune with what felt right. So, how deep do I mulch my tomato plants? As much as it feels right. It's, ish. Decently. Like, I want to put as much mulch down so that there's no chance that the grass seeds that are still in that mulch, if they germinate on the leaf, they don't touch, on the stem, they don't touch the ground and they can't grow. And if they germinate, they fall down and germinate on the ground, there's no sunlight, so they can't grow. I want a nice thick layer of mulch. And if you've got a well-functioning soil, that mulch will disappear in short order. A little bit of summer warmth and rain, and that mulch will like vaporize, and you probably have to put more down in the middle of the year. And then I would suggest by the end of August or beginning of September, you go through with your cover crops and you broadcast your cover crop seed right into your tomato plants and pepper plants and cucumbers and chard and kale and collards. I suggest you don't wait until the end of the year to pull your crop plants out, but you actually put your cover crops in right there with them, underneath them. When the frost comes and kills your tomato plants, let them fall down and let the cover crops be already 1.5 feet tall. Right? We can do much less work and have a much more well-functioning ecosystem. I think if we just are willing to think a little bit out of the box, then you get the problem of dealing with your cover crops if they're growing over the winter. I don't think I've said this yet, and I don't because I don't believe it. I don't believe in thou shalt not till. What I believe is as light a touch as possible. So if you can, there's this thing called the crown of a plant. You got a grass plant, and you got roots down here and leaves up on top. This right part right here is called the crown. If you can come through and separate the crown from the roots, you can pretty much kill most plants. I suggest if you disturb the top inch or 1.5 inches, 2 inches of the soil with the rototiller shallowly, and you can separate the crown from the roots, I don't think that's a deeply destructive process. It's when you go down 4 inches, or you go down 6 inches, or you go down 8 inches, and really till that soil up is when you cause the mass genocide associated with tillage and all the negative effects thereby. So moderation in all things. I don't know. Yes. Go.
can you maybe share any further words of wisdom about industrial organics? I mean, we've already had some, references to it already here tonight. I think probably many of us in the room would, admit to some ambivalence about industrial organics. And, we'd is preferable to, Cal Organic. But the fact of the matter is, industrial organics is raising a lot of awareness, and so there's just a lot of conflicting feelings. I think some of us have.
It's a
about this.
continuum. I mean, I happen to be somebody who watched my parents write some of the first organic standards in the 80s. Like, I remember my father coming home from the meetings and talking about the certification committee and the fights they were having. And then I remember being in 4th grade and telling my teacher I was this organic farmer, and she's like, organic means contains carbon. All farmers are organic farmers, you stupid child. And then, like, somewhere in like 8th grade, all of a sudden, everybody knew what organic meant. This new definition of organic, and then, like, the government came and took it over. And then it took them like 8 years to figure out what the regs were. They tried to involve, sewage sludge, and they tried to make it involve GMOs, and the people rose up and they fought it. And then they got the industrial supply chain. Then it became legal, and then slowly for the past 15 years or so, big business has been weakening the standards, right? And bringing in, and lowering and lowering and lowering and lowering the specs. And it's been a the mechanistic big business model. I went to this conference called the what's it called? Natural Foods Expo, I guess, which is like the